Imagine, if you will, a priest, a scientist, and a skeptic, all locked in a debate about the origins of the universe. The question of where we all came from has been a source of speculation for millennia, and it wasn't until the 20th century that scientific advances brought us closer to a definitive answer. The term Big Bang, the theory of everything starting from a single primeval point, was actually coined by a man who vehemently opposed the idea of a universe with a single origin point, Fred Hoyle. Now, picture a universe expanding from the days of Vesto Slipher, who noted a peculiar shift in the light spectrum of celestial objects. This observation served as proof of an expanding universe, an idea that was further strengthened by Albert Einstein's theory of general relativity in 1915. Einstein's groundbreaking theory painted a universe shaped and driven by the distribution of matter and energy within it. Fast forward a few years and enter Georges Lemaitre, a Catholic priest wearing the hat of a theoretical cosmologist. He was the first to weave together the threads of theoretical and observational work, proposing a universe that was getting less dense and expanding over time. But wait, there's more. From the idea of a primeval atom to the steady-state universe theory, there was no shortage of proposed explanations for the expanding universe. Amidst the sea of theories, a challenger emerged. Fred Hoyle, along with his colleagues, proposed a theory that stood in stark contrast to the idea of a single point of origin. They proposed that the universe held constant both in space and time, with heavy elements being born in the hearts of stars. But it's the twist in the tale that, but you'll hear more about that soon enough. What's up, my amazing and curious folks? Are you ready to unravel some mysteries with us today? I'm your host, Cesar Chagas, and with me is the vivacious and insightful Sonia.
Hi there, folks. Excited to be here.
And we're excited to have you here. Now, don't forget to subscribe to our channel, hit that bell icon, and join us on this journey through the Curiosity Wonderland. Get ready, because we've got a mind-blowing topic today. Let's dive right in. So the term Big Bang turns a whopping 75. But here's the catch. The name was actually coined by its greatest scientific critic, Fred Hoyle.
Wait, so the name of the Big Bang Theory came from someone who didn't even believe in it? That's a bit ironic, isn't it?
Absolutely. It is indeed a great twist. Hoyle was a frequent guest on BBC Radio throughout his life, and he simply couldn't accept the idea of the universe having a single moment of origin.
I guess we can say he just wasn't a fan of beginnings, huh?
Haha, you could say that.
But then in science, it's not about what we believe or what makes sense to us, right? It's about what the evidence tells us.
Exactly. The truth in science is determined by the evidence provided by the universe itself. It's not about popular opinion, authority, or intuition.
And the evidence started building up in the 20th century?
Yes, advancements in theory, observation, measurement, and technology during the 20th century led us to what we now know as the Big Bang Theory.
That's amazing. And what role did Vesto Slipher play in all this?
Vesto Slipher, he played a key role here. Back in the 1910s, he noticed that some objects in the sky showed a systematic shift towards either end of the light spectrum. This led to the idea of an expanding universe.
So the farther away a galaxy is, the more its light appears redshifted to our eyes and instruments.
Exactly. These findings set the stage for the emergence of what we now know as the Big Bang Theory. Now, it's interesting to note that Einstein's theory of gravity, general relativity, was another key player in all this. He imagined gravity as a geometric construct, with space-time behaving like a fabric.
So like a sheet that bends and warps where there's matter and energy?
That's a good way to visualize it. And if you had the exact ingredients of the universe, Einstein's equations could tell you how this fabric would behave.
And what about the faint, fuzzy, spiral, and elliptical objects in the night sky? You mentioned they played a role as well.
Yes, these objects, which were initially thought to be protostars or stellar systems in formation, turned out to be much more revealing. In the 1910s, Vesto Slipher discovered these objects were moving rapidly away from us.
So that's where the idea of an expanding universe comes from.
Precisely. Edwin Hubble in 1923 further supported this by measuring individual stars within these objects, demonstrating that they were galaxies of their own, at immense distances from us.
So as the universe expands, everything else is moving away from us, like coins on an inflating balloon.
Excellent analogy. And as this happens, light itself redshifts, or stretches to longer wavelengths. This visualization ties directly into the idea of the Big Bang Theory.
And that's because as the universe expands, it was smaller, hotter, and denser in the past?
Exactly. This major revelation was a surprise to many, including Einstein. But this expansion or contraction of the universe, as predicted by general relativity, was first shown by Alexander Friedmann in 1922. The Big Bang Theory wouldn't be complete without mentioning Georges Lemaitre. In 1927, this scientist, who was also a Catholic priest, combined Friedmann's theoretical work with Slipher's and Hubble's observational work.
So he was the first one who really put the pieces together.
That's right. He reasoned that galaxies were moving away from us because the universe was expanding and getting less dense over time. So in the past, the universe was smaller and denser.
And that's how he came up with the idea of the primeval atom as the origin of the universe.
Absolutely. However, this wasn't the only theory around at the time. There were also theories of tired light, an empty universe, and a steady-state universe.
A steady-state universe? That's an interesting thought.
It sure is. This theory suggested that the universe was the same everywhere in space and time. It was proposed by Fred Hoyle, Herman Bondi, and Tommy Gold in the late 1940s and became one of the central ideas of the steady-state theory.
So we had multiple theories for the origin and nature of the universe. How did we end up with the Big Bang Theory?
A good question. The primeval atom theory, another name for the Big Bang Theory, was ultimately accepted because it made predictions that could be tested observationally, and this was first done by George Gamow, a former student of Friedmann. He, along with Ralph Alpher and Hans Bethe, argued for the primeval atom through these predictions.
It's incredible how all of this came together to give us our current understanding of the universe.
Indeed, it's a testament to the power of scientific inquiry and collaboration. To truly accept a scientific theory, it's important that the theory makes predictions yet to be tested, differing from existing alternatives. George Gamow's work led to 3 significant predictions.
And what were these predictions?
The first one is the development of structure. Today we observe galaxies that are massive, evolved with a mix of young and old stars. If the universe started from a hotter, denser, more uniform state, we'd expect to see less massive, less evolved, but more numerous galaxies earlier on.
So the galaxies we see today are essentially the grown-up versions of these early galaxies.
That's one way to put it. The second prediction is about the radiation background. If the universe was hotter in the past, there would have been a point when it was so hot that neutral atoms couldn't form. Then, when things cooled enough, a bath of radiation would have been released, which we should still be able to detect today.
That's the cosmic microwave background radiation, right?
Correct. And the third prediction is about the formation of elements beyond hydrogen. At extremely hot temperatures in the past, the formation of stable atomic nuclei would have been impossible. But as the universe cooled, heavy elements began forming rapidly in a process known as Big Bang nucleosynthesis.
So the heavy elements we see today, they all came from the Big Bang.
Although the Big Bang gave us almost all of the hydrogen and helium in the universe, and almost none of everything else. Most elements, in some form or another, were actually formed in stars. Now, while the Big Bang theory rose in popularity, it wasn't the only theory around. Hoyle's steadfast hypothesis, or the steady-state theory, offered some different outcomes.
How so? What did the steady-state theory predict?
Contrary to the Big Bang theory, the steady-state hypothesis predicted constant structure across cosmic time. Galaxies would appear the same at all distances and locations. It also suggested that there would be no background radiation, only the diffuse glow of starlight reflecting off of gas and dust.
I see. Sheezer, and what about the heavy elements?
According to this theory, all of the heavy elements would have been forged in the interiors of stars, rather than anything beyond hydrogen arising from the early, hot, dense period in the universe. It's quite a different take on things.
It's surprising to think there were such different theories for the origin of the universe. What led to the decline of the steady-state theory?
Hoyle had some good reasons for his theory, but the observations didn't align. For example, the most distant galaxies known at the time appeared remarkably similar to the ones nearby. There was no detectable evolution, and critically, no low-energy radiation background had been detected, which we now know as the cosmic microwave background radiation.
So despite its initial appeal, the steady-state theory couldn't hold up against the observational evidence.
Exactly, Sonia. The Big Bang Theory, despite its name being coined as a critique by Hoyle, won out because it matched the evidence we see in our universe. Hoyle was absolutely convinced that stars could not produce light elements like carbon, hydrogen, and helium. But then he made an astonishing prediction related to the formation of carbon.
What was this prediction?
Hoyle proposed that 3 helium nuclei would need to meet under extremely hot, dense conditions to create one carbon nucleus. These conditions, he reasoned, could only be achieved inside the hottest stars. However, carbon would only be produced if carbon had an excited state, now known as the Hoyle state.
And was his prediction correct?
Yes, it was. In the 1950s, nuclear physicist Willie Fowler actually found this excited state of carbon. This led to the understanding of how most of the carbon in our current universe was created, through stellar nucleosynthesis.
So Hoyle was right about the creation of carbon, but what about the lighter elements?
That's where things changed. While stars might be the origin of heavy elements, they couldn't explain the abundance of lighter elements like hydrogen, deuterium, helium, and lithium. The discovery of the first quasars, galaxies billions of light years away, showed that their properties really were different from modern-day galaxies.
So the Big Bang Theory started to make more sense?
Exactly. And the final piece of the puzzle came in 1964, when scientists Arno Penzias and Bob Wilson stumbled upon an all-sky glow of low-energy radiation, peaking at about 3 Kelvin above absolute zero. This was the cosmic microwave background radiation we were talking about earlier. It was the evidence that solidified the Big Bang Theory. Over time, evidence for the Big Bang Theory strengthened. The glow of radiation left over from the Big Bang was measured by many different instruments across a wide range of frequencies. It was determined to match the precise spectrum predicted by the Big Bang, proving that it could not have come from reflected starlight.
So this radiation was not starlight, but a direct leftover from the Big Bang?
Exactly. It was a surprising discovery. Even samples of extremely pristine gas and stars were found, with very few heavy elements in them. Yet they still contained deuterium, helium, and lithium in the proportions predicted by the Big Bang nucleosynthesis.
I guess all of this evidence left little room for doubt.
Indeed. The evidence was overwhelming, and the 3 great predictions of the Big Bang were all validated observationally. Interestingly, Hoyle, despite being a scientist, didn't change his mind in light of this new evidence. He spent the rest of his days critiquing the Big Bang model and modifying his steady-state theory in attempts to keep it alive. Only after his death in the year 2001 was work on his alternative theory abandoned.
That's quite a persistence in the face of contradicting evidence. But what about the galaxies? How did they fit into this picture?
Yes, the galaxies. Younger galaxies that are like the Milky Way are smaller, bluer, more chaotic, and richer in gas than the galaxies we see today. But as far back as we have ever seen, galaxies obey these rules. This observation strengthens the Big Bang Theory even further. The story of the Big Bang didn't end there. In the 2010s, indirect evidence for another great prediction of the Big Bang came in, the cosmic neutrino background. This was revealed through its imprint in both the cosmic microwave background and the large-scale clustering of galaxies.
So this evidence further strengthened the Big Bang Theory?
Absolutely. These imperfections found in the cosmic microwave background provided key evidence that the Big Bang wasn't the absolute beginning of everything. It is thought to have occurred after a previous phase of the universe, known as cosmic inflation.
And the term Big Bang, where does it come from?
The term Big Bang comes from one of its greatest detractors, ironically. It wasn't given this name by those who worked on it or found the critical evidence for it. Can you believe that?
That's quite unexpected. Who was this detractor?
It was none other than Hoyle, the one who could not bring himself to say those three little words, "I was wrong." Despite his opposition, today the Big Bang is an inextricable part of our shared scientific history of the cosmos, and its name is forever linked to Hoyle, the one person who rejected it more strongly than anyone else.
That certainly is a twist in the tale. The history of the Big Bang Theory is as fascinating as the theory itself.
So to sum up, our understanding of the universe has been shaped by a fascinating journey of discoveries and debates. The Big Bang Theory, which offers a compelling explanation for the origins of the universe, was ironically named by its biggest detractor, Fred Hoyle. Even when faced with insurmountable evidence, Hoyle clung to his opposing view. His rejection of the Big Bang Theory was so strong that it forever linked his name to the very theory he refused to accept.
It's a bit like naming your dog after your least favorite vegetable, isn't it?
Haha, exactly. It just goes to show history often has a sense of humor.
Indeed. And thank you to all our listeners for joining us on this cosmic journey. If you enjoyed this episode, please blast that like button, share your thoughts in the comments, and don't forget to share this episode with your friends. Let's keep exploring the universe together on Curiosity Wonderland.
And as always, stay curious and keep asking questions. Until next time.
Goodbye, everyone.
I stumbled upon this interesting piece on the Big Think site, titled, "The Big Bang Turned 75 Thanks to Its Greatest Opponent." It was penned by Ethan Siegel and published on March 5th, 2024. If you want to dive in deeper, we've included the full URL in the video description. Now, I'm off.